You saying you can make it actually sound good?
Mm-hmm.
Oh.
Very good.
It's hard to do with sex organs.
I mean, depends.
True. Sex organs never sound good.
Well,
I mean, it's just like the sound of a normal organ, but it's kind of squelchy.
that was labored.
I mean, that comes much later.
Oh, right, of course. So day one?
The first day.
The first day. Dawn of the first day. We have pictures. We have pictures of dawn of the first day.
We do. And I forgot to tweet at GSA.
Dawn of the first day?
Yeah, I've done
You
that
promised
every year
that.
for the last
Oh,
3
you
years,
promised
and I
that.
forgot this
You
year.
promised that.
I was busy doing not my talk.
I know. Speaking of which, I need to probably finalize my talk.
We need to practice that.
That needs to probably go into like at like one of those electronic things that you go. It's called a computer, right? Yeah.
That will go in Monday.
Probably digitize
Fuck.
that.
That's tomorrow.
I need to finish my talk.
Yeah.
Okay, let's see what talks I'm not going to see tomorrow morning.
I appreciate that this is where we're at right now.
I'm glad that I'm not one of you two.
Okay, that you don't have to do a
That's a
talk.
common experience.
So
I could pretend to be one of you two.
So we're so James, we're joined by a friend of the podcast, Anna.
Hi.
So, Anna, what talks did you see today?
Yeah.
I went to the evolution of paleontological art session.
That is awesome because I wanted to have because I think Brendan finally did go to some of that, so we might be able to hear more from him. But I would love to hear what you saw on that.
It was cool.
I did not have the chance.
The invited speaker, he was talking about William Smith's fossils, like
Yeah.
the guy who did the original stratigraphy work in Britain. So they're re-releasing some of his original publications because he didn't finish them, right?
Yeah.
He went to prison.
Wait, really?
Yeah, he was in debtor's prison.
Oh, okay.
So
not real prison. Just
not
poor
real
people's
prison. But I don't know. Being in debtor's prison and
Being in debtor's prison counts as real prison.
Yeah,
it's
I don't
just a
think that'd be
prison
fun.
that you get put in because you don't have a job, so then you can't pay off your debt, so you stay in prison.
No,
right.
I understand the concept. I'm just saying it's not real prison. It's cushy prison for people that haven't bothered
What?
to work.
No.
I don't think debtors' prisons were ever like
No.
white collar.
You weren't
prison.
in there with murderers, were you?
I don't know enough about debtor's prisons to talk about
I mean,
it.
not at first. They become murderers while in debtor's prison. But
You've just invented like a Saw equivalent of debtor's prison, haven't you?
no,
somewhere
it's
in your head?
incredibly Darwinian.
Okay, that's Saw. You just described Saw.
Maybe neo-Darwinian.
James, you have to tell us something. Have you been diagnosed with something, and have you ever got a real interest in puppetry right now?
Puppetry is intriguing.
It's very
no.
intriguing.
I've never been diagnosed with anything.
Okay,
Alright.
but would you like to play a game?
Games are for children.
There. So,
Yeah, talk about
continue.
art.
That was really
Yeah.
cool.
So they're re-releasing a bunch of his illustrations with the actual specimens that are still in the natural history collections.
Okay.
We also saw some 4M art. So we saw the original ones created in the 1600s. So that was pretty cool.
Okay.
Moving and then up to SEM images. So they talked about kind of the changes that
Yeah.
went along with that. And they also talked about the Crystal Palace dinosaurs and how we almost had the same thing in Central Park. Except apparently there was like a mafia thing
It got
involved.
trashed.
Yeah, and they smashed all of his stuff. So that's why we don't have dinosaurs in Central
Yeah.
Park.
No, it's true.
Yeah.
I read about that.
That's cool.
Yeah.
So,
Apparently there were bits of them, like, they didn't find all the bits, so somewhere in Central Park there's like...
Yeah, apparently
there's
they're
just-
still buried there
Yeah.
somewhere. I saw that on Twitter, so you can like go fossil hunting in Central Park for
Mhm.
like concrete dinosaurs.
when the
So
mafia wants
someone
to
should
get rid of
definitely
something,
do that.
Yeah.
they bury it deep
Yeah.
so that nothing can ever find it.
Like Jimmy Hoffa.
Yep, it's right next to Jimmy Hoffa.
Well, of
so-
course, yeah.
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 Why bury in two spots when you can just put everything in one place?
Makes it much.
I mean,
more
Jimmy
convenient.
Hoffa was in the Concrete Dinosaur, wasn't there? Oh, crap. Too obvious.
Right.
Oh, that makes sense. What a clever way of no. Okay.
In fact, that's where the line "clever girl" comes from, because it was a female
Oh, yeah,
mafioso
yeah.
who came up with the idea.
Of course. Clever girl. What?
I think it'd be mafiosa in that case.
Yeah.
Yeah.
I don't think that's also. I don't think that's actually how that works. I don't think that's.
I'm pretty sure it's almost Latin.
So.
Almost.
It's like poor Latin.
Did you? Were you there to see Warren Allman's talk about the T-Rex drawings and how we're still getting it wrong?
No, unfortunately, I missed that
Okay,
one, and I'm really disappointed.
That's one that I wanted to. I was hoping that someone had that.
Was it
but-
T-Rexes? Children are still dumb.
No, I don't
Okay.
think that. No.
Okay.
No.
Because when I used to draw T-Rex, I remember the progression I had, where for a while, because I realised that feet had multiple claws on them, I'd draw the feet on their side with claws all the way around them, and so I was drawing like an Egyptian, where certain things were like
Oh yeah.
perspectively weird. And I remember doing that.
So do these still exist? Can we still see these?
They're probably in my art box back at home.
So they're locked, but yes.
Yes,
really,
they're
no.
still existent, so
Ants,
we need to find
ants,
these and
ants.
show them.
I'm not ashamed.
No, it's
You
not.
shouldn't be. Obviously, these are gems to be shown to the world.
I also remember I used to draw a lot of dinosaurs, and my grandmother once said, "Can you draw ones that are friendly and not killing each other?"
So that's another thing they were talking about art. There was
like the constant murder of
yes,
dinosaurs.
how it's animal centric and they're always violent.
Yeah,
So whereas the plant centric, peaceful interpretations that didn't show up until much later.
Well,
if you think plants are peaceful, you're not looking at a fun enough scale.
Well, and also like it's still a predator-prey interaction when it's a stegosaurus that's eating a little bit.
Exactly.
Where's the stegosaurus just having a quiet, happy poop?
And
Well, what if he's slightly
the
straining?
end digestion was not covered. Like we did not get to that part.
It's
it was
just
only the initial.
little bead of sweat on his face. It's a very bad day.
That's the evolution of like spiciness. That came in angiosperms. That came much later.
That's fair.
Than
Well,
Could
no.
dinosaurs-
that. That was the birds.
But birds can't. Birds
Birds
can't
can't
sense
sense
capsaicin,
capsaicin.
so dinosaurs probably couldn't either.
True.
We need to see if crocodiles can.
Oh,
We can
yeah,
try to
okay.
bracket it.
So what you're saying is we stop this, then we mail it
We
to
need the
ourselves,
bear
and
spray
it's just going to
crocodiles.
be an NSF.
That's what we do. We sell bear spray, but we just slap a picture of a crocodile on it, sell it in the Everglades, and if people start dying, we know that they can't tell capsaicin.
Also, like, when would you use that? In the split second the alligator jumps out and nearly kills you? Like, oh god! Thank god I had my alligator repellent
maybe
in
it'll
my
bite
hand.
it.
No, you
Spray it.
you directly spray it onto you, especially in the face, to ward off the alligator.
That's a story that I think is apocryphal that I remember hearing about someone with bear mace.
Yes, I heard that story too. They're
Yeah.
like, don't take it out because you will spray yourself in the face.
So it's bear repellent. Cool. No.
I remember seeing videos of Canadian riggers spraying a bear with pepper spray, and the bear going, "Oh, this is good," and then
Yeah.
it was like, "Fuck off, bear!" and throwing.
Well, no,
stones
that was your favorite video of bear.
Oh, is that the bear? No, bear.
Yeah, no bear. No.
That's not food.
Yeah.
That's not food, bear. Yeah.
Isn't that where it just destroys a kayak?
Yeah, it's eating the
Yeah,
kayak.
So I spent most of the day in the phylogenetic paleobiology section because that was also kind of outside of the paleo art, the only other paleo session
Yeah,
today.
there's kind of a lack of them today.
Yeah.
It was good. Like there was cool stuff.
Yeah.
Lots of. So I don't know. In terms of stuff to talk about, do you want to talk a little bit about Pete's talk?
Sure.
That was fun.
Yeah, no, that was good. That was a fun talk. That logically made sense to me as well. So
Yes.
that's good. I understood it. At least the basics of it. It
was-
had Bender.
It had Bender. It had Bender, which again, it's always good.
And a broken emoji.
And a broken emoji. That was sad. That was
Yeah.
sad.
A broken emoji.
Okay.
Yeah.
So so a lot of the session today was methods and modeling and like figuring out how you can apply these different methods and which methods work best under certain situations. So Pete was looking at methods for reconstructing how characters change over time.
Mm-hmm.
Okay.
And he's like, so we are pretty good at like treating things as independent. But the problem is, we understand from developmental biology that if we change one thing, we can inadvertently change 4 or 5 other things.
For example, like complete random out there example, losing a rib cage is going to have major effects on all of your internal organs at this stage.
Yes.
Yeah.
Including the pelvis.
Are you suggesting that the pelvis is an internal organ?
I'm suggesting it might hold your internal organs.
No.
As for some research.
Your pelvis would have to get bigger to hold more
No.
organs because they'd all be down at the bottom.
No, this is not.
You'd have to go from basically like a taco bowl to a big salad bowl.
Right. Or you could just have a really big taco bowl.
Make taco salad.
Yeah.
Make it-
What happens if you have a taco salad?
So if you had a taco salad, that's an instance where you have both the salad and the tacos, and maybe at that point we've got some co-variation
yeah, so they're
occurring.
not
Yeah.
independent characters.
It's not entirely
Yeah.
independent.
Exactly. Okay.
So he had this example being like, so if this thing varies, but everything else varies, and it's like terrible. And so he had one emoji with a really big smiley face, and a bunch of emojis like, oh, really sad.
Various variations of sad faces.
Variations of
Okay.
sad, terrified, or dead. And then one was a square. And he's just like, well, that emoji broke.
And then I don't know if they'd moved or not, but then underneath them was just 3 daggers.
Yes. Well, because the idea was like...
That results in death.
Yes.
Yeah.
Because
Yeah.
it was like, it was...
Yeah.
Unhappy was okay, like it was maladaptive, but it was not like it. Like
Yeah.
it balanced out for the selective advantage of the thing that was changing. But like the ones that were doing basically the version of the scream, it was dagger, dagger, dagger. It's like, and that'll kill you. Like that's just gonna be a problem. It's like, so this is an example of developmental constraints. Like we have this one thing, we can't change it because if we change it, it kills you.
Okay.
We have lungs. We're stuck with that current breathing apparatus unless something drastic changes. So then he was like, but clearly developmental constraints can't be perfect because we don't end up with this trend of like everything gets stuck and then can't ever evolve anything new. And so we know that there's a possibility to break down those constraints, but it has to occur when we get something that's really amazing that evolves, that's so good that the other things that suffer either have to either are good enough to keep going or eventually are sort of decoupled from the rest of the system, and the biological components are having to sort of redo older ways of generating those characteristics, kind of going through a different developmental pathway.
Yeah.
And his picture for the thing that is so awesome that it changes the system is just Bender with a bottle of booze.
Yeah.
Good enough to keep going.
Good enough to
Title of my autobiography.
Exactly. Good enough to keep going. Like, the one thing is great, everything else is terrible, but this thing is so great that it's like, okay, fine, it'll change, but then realistically, the next generation, a lot of those things, if they can, are going to change back to the way they were.
Yeah.
Right.
Yeah. And he was saying the point was, okay, so we understand this, and maybe...
But we don't model it.
Yeah, and so maybe over time, how tightly linked these characters are is going to change. And so the interesting thing is trying to assign a value or weighting to how tightly linked these things are. And he said that where we tend to think about it, it's very intuitive. So the examples he gave were teeth and reproductive systems, where we know everything is very interlinked. And so we kind of have a good feeling for how things are going to co-vary with each other. But for everything else, we don't understand it all that well. And so this is where what he was doing was then coming in and trying to model it and look at essentially likelihoods.
It was, and the cool thing that he was running through was he's like, there's a expected change, which is you're going to get this thing, then it's going to get modified, then you're going to get this thing, then you get this thing. But if it's a covariance where the one thing evolves, forces everything to change, and then they kind of have to go, oh god, we're going to end up varying the thing on the far end, which is going to end up with a kind of reverse direction until the system stabilizes again. And so he was looking for instances in data which actually sort of fit that weird violation of expectations.
Yeah.
That was cool. That was fun. I enjoyed that talk immensely.
Yes. Yeah. It's understandable. So I was mostly in that session. There was a couple of things in the afternoon. There were 2 talks back to back looking at essentially disparity in different groups. One was in mosasaurs, and the other one was in anomacarids.
Yeah.
Ooh, Mosasaurus.
The
Mosasaur
Mosasaur one
one's
was
cool.
very interesting, and I've seen it's Josh Lively. I've seen him give talks before on Mosasaurs. I cannot remember what they were on, but they were good.
Okay, well, they were on mosasaurs.
Yeah, well, I know that, but I don't know what aspect. And this was looking at describing a new species, which shows extreme heterodonty, which was interesting in and of itself.
That was so weird.
What?
Yeah, it's got crushing teeth at the back and stabbing teeth at the front.
And it's a mosasaur.
God. The Cretaceous seaway is just so weird. I don't like it.
Says the person working it.
Says the person who lives in Kansas.
Yeah. And so he was looking at the phylogeny, and that is kind of in flux. And there's a really interesting phenomenon now in all these talks where usually, and this is partly because of the session they're in, and he said this, like, well, I thought because it's a phylogenetic session I should do a lot of phylogenics, so I did Bayesian as well, and here's the same results with more polytomies, and that was pretty much every talk.
That was every talk. That was every talk. It was here, we did parsimony, and we did Bayesian, and it's basically the same, but it's less resolved.
But he was basically looking at one of the big questions now in mosasaur phylogeny is, are mosasaurs real, or are they just becoming snakes? Or are mosasaurs evolving independently multiple times? And it's kind of up in the air a little bit more.
The idea that mosasaurs became snakes is like a...
It's a thing?
Yeah.
Oh.
Mhm.
I'm not up to date on my mosasaur research.
So mosasaurs ate the apple,
Yeah.
and then they lost all their limbs and
Of
became
course.
snakes.
Mm-hmm.
Okay.
Yeah.
But when was... So, were they in the process of losing their limbs when they went to the water, or is this just... They came out of the water and then ate the apple?
When was Noah's flood then?
Oh my god, we cannot.
During the seaway.
We just cannot.
It's losing its limbs while flooding in the seaway.
Okay.
And then it convinced Adam and Eve, it went back in
Oh my
time and
god.
convinced Adam and Eve to eat the apple again so that the flood would happen so it could lose its limbs.
Why does it want to lose its limbs?
Because it's a snake.
Okay.
This, this hypothesis of yours, I think we need to take this. We'll mail it to ourselves
Yeah.
so that we can then make
Yeah.
sure that we copyright it.
We'll
and
keep
then,
it in review forever.
Yeah. Yo.
Don't give away your plan.
Oh.
It's
It's a joke that no one will get.
the best kind. And so so there was interesting stuff looking at the phylogeny, and basically this thing is sort of filling into a slightly weird place, but then he was looking at the disparity.
Yeah.
And basically these things were becoming they hit a peak in disparity around, was it the late mid Cretaceous? Late mid, early late?
I can't remember specifically.
But there's a point where they sort of peak in their disparity and then they start to tail off again.
Yeah.
But he was tying this partly into the dentition in this thing is weird and it doesn't fit clearly into any groups, and they're clearly being very, very experimental and fulfilling a wide variety of ecological niches in terms of their diet, more so than people have been thinking.
What other niches other than grabby have they fit, other than this crushing one that you just found?
That might. There's the difference between sort of being piscivorous and also attacking other like large vertebrates.
Okay.
Which is a potential difference. But he was largely looking at just like the occupied space and the increasing disparity, and sort of saying that based off that, and then tied into these dentition shifts that we're seeing and the fact that different groups are doing slightly different things, there's clearly a diversity going on in their diet. But then he kind of said, and there's more to this, which I'm going to talk about next year.
Yeah.
So I don't have a firm answer necessarily to your questions.
Okay.
Other than these, there are mosasaurs that are weird, and there are some that are trying to be platycarpus by the looks of it.
I appreciate them for trying.
Yeah. And then the anomalocarid one was doing the same thing, but with anomalocarid's. With the big caveat that there were a lot of slides, and no slides stayed up for more than a few seconds, and so there was a lot to unpack that I couldn't quite unpack.
Yeah.
I feel bad bringing this talk up because I think I disagree with parts of it, but I'm not sure because I couldn't see it for a long period of time.
I also feel like it felt like someone's first presentation.
It wasn't, because I've seen him give presentations before.
Okay, never mind.
But it was probably the first. I think it was their PhD. By the time.
It was a lot of information to go through, and it felt
like when I gave my defense talk in 15 minutes.
Yeah.
Time at GSA.
Yeah.
Yeah.
So I understand that.
All 121 slides of it.
How many slides is that a minute?
Oh, it was too many. I started skipping through them towards the end.
I'm gonna do the math.
You're gonna actually do how
I'm gonna do the math.
how many seconds he could
It would have been
reasonably
10 slides.
15
10 slides a
times
minute.
60 divided by how many slides do you have?
Oh, 121. Well, 149 in my defense. I got
149.
some out.
You
so-
got some out, so 121.
That's 7.4 seconds a slide.
Yeah, people love my defense.
I can imagine.
Yeah, and it was really good fun to do it in 12 minutes. So, but yeah, he was looking at revising anomaly carried phylogeny and revising anomaly carried disparity and their ecological roles, and looking at why there's basically this possible turnover where Herdians, which are anomalocaryds with these very, very large, robust head shield plates. They've got these lateral plates that run either side of the head.
And
one
they
across
look
the top.
almost like if you ever seen a bivalved like shrimp or a shrimp-looking thing or an arthropod.
Okay.
They look kind of like that, but they got the little anomalocarid things going.
There's a bunch of them in the K Naturalist Museum listed as bivalve arthropods.
Guess I'll have to change that.
You can probably publish a paper.
Yeah, I mean the only reason I know that is because the paper on Herdia came out while I was there, and I was like, all these things aren't actually. But so Herdia plates are actually very, very common in the Cambrian fossil record in these Lagerstadt. It's just that people haven't been recognising them because Herdia was only described in its actual morphological form in 2014. And so he's saying there's this turnover from anomalocaris type anomalocaryds to Herdia type anomalocaryds, and why does this happen? And he tied it to this carbon isotope excursion, which is associated with the breakdown of archoceratid reefs, which is a big ecological turnover. They're the first major, well, not major, but they're the first kind of any reef builders, and they all die out.
Mm-hmm.
But he also tied it to an extinction in trilobites and said, well, anomalocaryds ate trilobites, which is something we don't know if we believe anymore, really, because their mouth parts are a lot softer than we thought they were.
We've all seen, like, the reconstructions of them grabbing them and chomping them.
It's a pretty every picture you see of the Cambrian is a
Right.
picture of an anomalocaris eating a trilobite.
With-
Honestly,
Back
every
to animals have to kill animals.
until you get to the Devonian, every picture involves a trilobite that's dying.
I mean, it's the natural order of things. And so he was looking at that, and again, like the thing that I was kind of there was this isotopic excursion. There's clearly something going on in the environment, so that's interesting, and there is this turnover happening. But my two caveats are: is I think Herdias are occurring early on. We're just missing them. We haven't known to look for them, and trilobites maybe are not the primary source of prey for anomalocaryds.
That's been an interesting debate. I remember when one of the people involved in that debate came to KU to give a talk, because it's the question of they've got the pineapple ring mouth, and do they actually have, because it's not mineralized, so is it possible to actually break up a hard mineralized trilobite?
And so he was looking at the disparity, and of course it goes up at a certain period of time. He was looking at the sweep feeding anomalocaryds, and there was some interesting reading of phylogenetic tree topologies to suggest that actually they have evolved convergently, which is what everyone has always said. So I wasn't too sure about the reading of the tree for that. And there's a thing where they're including juveniles as
and
well.
adults, but they didn't mention that in the talk. They
No,
just said
it's
they
just
were
like-
including more taxa. But
Yeah.
it was like they were including the teenagers. It was written on there. You just had to see it, and it was a kind
Yeah.
of blinking and missing.
And there was one taxon which was labelled Jove adult. And the really interesting was that the adult was lower down in the phylogeny than the juvenile was, which is kind of the opposite of what you tend to expect when you're seeing that kind of relationship represented phylogenetically.
Yeah.
And so there's just a few things in the methodology where you couldn't see what was going on because he was going through so much.
Yeah.
And then there was a bit of a discussion about, and there's this giant gap in the fossil record for the late Cambrian into the Ordovician. And then basically this is ongoing work,
Yeah.
Mm-hmm.
you know,
Yeah. Which again, I mean, there is a gap. We have Devonian and Anomalocaris.
yes, there definitely, yes. And so that was that, and so it's interesting to see more people look at the disparity,
Yeah.
because it's something that other than like Mike Foote was doing in the late 1990s and nobody cared about it. Matt Wills did some stuff, nobody cared about it, and now it's sort of come back around
It's
again.
become something
it's
that
become more widespread.
lots of people look at.
Yeah. So those were the two talks in that session.
I mean, you missed Davy's talk.
I saw pictures of Davy's talk through the door.
Yeah, he was looking at the timing of the Great Ordovician biodiversification event using.
Didn't he put it in the Cambrian?
So no.
Okay.
So he called it an informal supertree, which means that it's according to your specific terms. It would not be considered a supertree. But he's, they've stitched together all these different evolutionary relationships of individual clades, made a massive analysis, and then used that informal supertree to do a fossilized birth-death model to reconstruct rates on the tree. And what he finds is an origin for the crinoids and the Cambrian, but they don't do much.
Okay.
And then as soon as you hit kind of the beginning of the Darwinian, or the Dupangian, we start increasing. And it doesn't correlate with oxygen. It doesn't correlate with a lot of the other associations. The other interesting thing he's finding is that there's no clade related or evolutionary. There's no specific change that certain groups are evolving at certain rates because they've got some innovation. It just seems to be that these things just start radiating. It's like they've hit either an ecological threshold, or there's some environment, or it's more of a. He didn't talk about a geographic stimulus because that just was not part of it, but that's another possibility that he didn't suggest. But essentially, that it's not like it's not a suggestion of selective force or success. It's just all of a sudden we get a lot of them.
Okay, almost like a threshold critical mass kind of thing.
Yeah, but like for a long time we're not doing anything.
Yeah, so it's like the Gould sigmoidal curve for the Cambrian explosion, where it's just you until you reach a certain point, you're suddenly going to then exponentially diversify just because of the way.
I mean, again, don't know in terms of that. But.
Cool. I guess I saw a few other talks, but the only one that I made major notes of was the last talk I saw, which was Adil Klumpmaker's talk, looking at. He's been doing work on lobsters and crabs in the Mesozoic. Crabs evolved from lobsters, and he says there's this thing called carcinization, which they do, which literally translates as becoming a crab.
Okay.
Where lobsters become crabs.
Crabinization.
Yeah, and so for a lot of the Mesozoic, you've got these intermediate crabs, which are lobsters that look like crabs, and then crabs that look like lobsters, and they're just end members of the same thing. And then into the Cenozoic, you've got crabs. Okay. And so he had data for all of the Mesozoic.
Once you get into the Cenozoic, you get crabs.
Yeah.
Terrible thing.
It's just bad.
But he was looking at basically body size, and throughout the entire Mesozoic, body size is increasing in crabs. And then he said, so what about the Cenozoic? And then you look at the Cenozoic and it just plateaus. Like average body size just stays the exact same. And then he was looking at different environments, and it's like, yes, on reef, off reef things are bigger than on reef.
Yeah.
And that's consistent, and those relationships don't change. So even though the trajectory is changing, the relationships don't change. Everything then stays the status quo into the Cenozoic. But then he started teasing it apart further. Maximum body size keeps increasing. So although which means that the average number of small crabs must be going up as well.
Okay.
And so maximum body size continues to increase into the Cenozoic. But then the thing that he said that was very interesting was that basically length-width ratio changes, so crabs consistently from the Mesozoic onwards are getting fatter. And this is because part of carcinization is the fact that lobsters start to get squat, and so instead of being elongated, they're squatter, and then they're broader than they are long. And he said, so there's two interesting things here. Why is body size increasing? Maybe it's because oxygen is going up consistently in the Mesozoic, and then it sort of plateaus off. Then the question is, why are they getting wider? And why does that then fixate?
They're just eating a lot.
No,
yeah, I understand why I'm getting wider.
Okay. You stop growing outwards and you start growing upwards. And the other way around. You start growing upwards, you start growing outwards. That's called like your mid-20s.
Yeah. Enjoy that.
Thanks.
Yeah.
But he had a very interesting idea, which was that the longest axis of a crustacean dictates which direction it walks. And so lobsters move forwards, which means they only move forwards, they don't go backwards.
Yeah.
Crabs move side to side, which potentially means that they have greater juking capability for avoiding predators because they've got two directions they can go instead of one.
Yeah.
And so
I've seen crabs and dogs.
Yeah. And so it's like, so maybe this is partly being reinforced by this like predator avoidance strategy. And then there's other things he wants to look at, which he hasn't had time to look at, which is that as you get broader, it's increasing your gill surface area in relation to your body size.
Okay.
So there's also potentially that as well. So it's really interesting. And he was saying that even when you include the Cenozoic stuff, where it plateaus, evolutionary models, Akaiki's criterion, keep suggesting that it's a directional movement.
Yeah.
It's just it hits this point, and then it's like, no, we're good.
Okay.
And so that was interesting. It was
Yeah.
very interesting. So yeah, that was the last talk I saw.
Okay. Do you see any other specifics?
Did you see Bacchus talk?
No.
Oh, okay.
Oh man.
I don't know.
I liked Lena's talk.
Yeah, I must admit, I looked at that talk and I'm like, okay, it's really cool somebody's looked at this, but this is just reinforcing my worldview entirely. It hasn't
What?
changed my opinion
What?
and the way the world worked. That it's cool for somebody to do that,
Yes.
but it was
Yeah,
what I
yeah,
expected the result to be.
Yes, it was cool for someone to do that. It's almost as though we wrote a paper that said, hey, more people should be doing this. I'm kind of flabbergasted right now that your entire...
No, but I'm saying the results were not revolutionary to me at all.
Oh,
They're
come
exactly
on,
what I
That's
expected.
that's okay.
That's okay.
Yeah, no, I know.
And it's also great when it's done with a lot of
Yeah.
robust different data
I like the
sets.
fact that people now don't ecomorphous spaces, which I've talked about ages ago, and it's my fault for not having done.
Yeah.
But
No, it was cool. It was looking at taking that big super tree that
Yeah.
Davey and her had been making for a long time and putting up some ecological characters onto that tree and seeing how it varies. So looking at community structure through time and seeing whether or not certain species are giving rise to other species with similar community strategies. And
there's a
it's
conflict
messy, but yes,
because it's almost like there's two competing things going on.
almost as though.
Yeah. Me saying this didn't change my worldview at all. I know you make it sound like a bad thing, but it's like, no, this is just how I thought the world worked. And
Yeah,
so-
that's okay. That's fine.
yeah.
This is the guy in the giant chair.
I mean, this is James's worldview.
Yeah, we're all just living in it.
That was a cool talk.
Yeah, that was a really good
That
talk.
I almost missed because the app deleted all my afternoon talks. So
yeah, beyond that, I saw a few things. There was one that I think Brendan probably has the most to talk about, so we can either.
is this the macroevolutionary trends of Marvel type?
No. I mean that's a cool talk.
Yeah,
but,
that was good. I missed the first intro slide, but
it was the one beforehand, which was looking at revisiting Chetham's data on punctuating equilibrium.
okay. No, I did not get to see that. I was
Yeah.
seeing a talk on plant disparity.
Yeah. Oh.
That was not an actual talk.
Oh,
that's been
right,
given
yes,
yet.
yes,
I was
right.
seeing the talk because I'm not going to get to see the talk.
Right. Okay.
So I cannot talk about that.
Wait, you're not gonna be able to see that talk?
It's
Oh.
during our session.
Oh, I thought she was in our session. No. Okay, she's not.
No, she's in the terrestrial ecosystems.
Gotcha. Okay.
Yeah, there's 3 paleo sessions going on Tuesday afternoon.
So cool. Once again, we got screwed.
Yeah.
Hooray.
Yeah.
It's gonna be tough to choose which one I'm gonna go to.
You don't need to go to anybody that are talks. You don't
Right.
need to be in the entire session.
There's some cool
No,
talk.
there's some very good talks.
Yeah.
I know.
I would say
There'll be some talks with actual data.
I would say you want to learn about carnivores. There's Blair Van Valkenburg.
Yeah. Now that you're a vertebrate worker.
Okay, don't lump me. Don't do that.
Wait, whoa, okay.
Whoa. Watch the accusations there.
You're the one that got excited about mosasaurs.
Yeah, because they're becoming like weird. That's
Because
all.
they're becoming snakes, which are honorary
Yeah.
invertebrates.
Wait, that's not moving your legs. That's not how that works.
I mean, I'm a Slytherin, so I can. do
Okay,
it all.
yeah, of course.
I can define snakes how I will.
Sure.
So can J.K. Rowling apparently.
So does anyone have anything else they want to add for day one?
No, other than this conference center is garbage, and has no food on site and is too
No.
big for purpose. So there's not even any coffee.
Oh
you
wait,
get.
can we talk about the Yu-Gi-Oh competition?
Yes,
Oh,
going
yes.
on?
there's a Yu-Gi-Oh competition first
Yeah.
of all.
And it's
and-
very easy to identify the Yu-Gi-Oh people in respect to the geologists.
And it's even easier to tell the tiny cheerleaders
Yeah.
from the geologists.
I did like when they started wandering around looking into the paleo meetings.
Yes, so we can maybe convert, underage cheerleaders
Well,
into
I can
paleontologists.
imagine that they were kids being like paleontologists, and then they looked at it and were immediately disappointed
Yeah,
and
like,
probably
that's
away
me.
from science forever.
yeah, yeah, yeah. Brendan is trying to call us, probably to find out if we're going to do a podcast.
Oh dear God.
Sorry, Brendan, we've done it.
Oh, we're gonna have to stop this and yeah, we'll see y'all later.
Yeah.